Hello, this anchor test will concern the testing of these three anchors with their roll bars removed. We have a 17-pound Mantis M1, a 12-pound Viking 7, and a 3¼ pound Mantis Dinghy anchor. Now, straight off, I want to say I do not recommend that you anchor your boat with roll bars removed. There's certainly the possibility that the anchor may land or become inverted, and if that happens without the roll bar installed, there's virtually no chance that the anchor will self-right. We can debate the likelihood of that occurrence all you want, but again, I'm going to recommend that you not anchor your boat. Why am I doing this? Mostly just to satisfy my and many of you viewers' curiosity. I do like to study how anchors perform, and curious how these various design elements affect the anchor. Now, I did have three sort of theories or predictions going into this that I'll share briefly. The first factor, I believe that roll bars in some situations might increase performance simply because the roll bar itself will provide some resistance in the seabed. Conversely, I've noticed that roll bars might contribute to an anchor's sort of grabbing or clinging to seabed, and in some substrates, such as my sandy mud, when that substrate breaks free from the surrounding material, you now have this new blob-shaped anchor, then that just doesn't work very well. The anchor will pop out and have very low holding power. A third factor that I theorized was perhaps the removal of the roll bar might affect the attitude of the anchor. Certainly the geometry of the anchor, mainly the placement of the attachment point, is going to be the main driver for the attitude. Also, the angle that the rode is pulling at is a factor. But the overall resistance of the anchor will be in equilibrium, and if you remove this roll bar, we'll have less resistance in this location. The toe will still be here with resistance on it, and that may tend to pivot the anchor more downward and perhaps have it plunge deeper and make more holding power. Now, it turns out that my three theories, if they were in effect at all, were overshadowed tremendously by another factor. So check out the footage. Incidentally, I did do all three of these anchors, multiple tests in two different seabeds, the sandy mud and the soft mud. Those two seabeds, although they kind of appear similar, they have completely different characteristics in how anchors behave. Enjoy. I will start off with the 17-pound Mantis M1 here in the sandy mud. This is with the roll bar installed. I'll show you three pulls to establish a baseline. We're seeing here at 580 pounds, the anchor is making usable resistance. But then at 630 pounds thrust, the speed of the anchor increases, followed shortly by a full release. Noted that the anchor was completely upright, there was no rolling, and I'm going to call that sort of a pop-out release, and we see that it does reset. Here's take two, same test. This is 5-to-1 scope with just short chain. Again, sandy mud seabed. This second try here was on the same day as the first, and it was the exact same result. A slow drag at 580, and then at 630 pounds of thrust, speed increases just for a bit, and out the anchor pops. Again, straight up and down, no rolling whatsoever. So keep an eye on these behaviors, because you're going to see something very different when the roll bar is removed. And again, the numbers were the same. 580 usable, 630 release. And here's take three. This happened much later, about a year later, different test boat, slightly different thrust numbers because, well, it's a different power plant. Here we had 620 pounds of thrust with a little bit of motion. Then at 685, motion increased, and it actually stayed engaged for a considerable distance. So it's a little bit better performance. Probably just an anomaly. Possibly the calibration of the thrust is slightly different for each test boat. So let's call it 590 pounds of usable resistance, and each time the anchor remained upright, no tendency to roll, and sort of a pop-out release with the roll bar installed. Now let's look at three pulls with the roll bar removed. I did have a fair bit of boat motion there on deployment. That ensures that the anchor flies down there in the upright position, so it was 100% setting for all these tests. Again, because there was a fair amount of boat motion during the deployment. So here the anchor is resisting 395 pounds nicely, but when thrust increases to 465, the anchor begins a roll. I've got the playback speed slowed down to 25%, and you can see that the anchor developed about a 90-degree list, mostly released, but then it rolled back upright, reset, and then it repeated that same exact performance. Did it twice, but you're going to notice here that it rolls the other direction this next time. So again, it was fairly solid at 395, then at 465 it began its roll, and sure enough, just exactly the same thing, but rather than rolling sort of in a right-hand direction, we'll see here, again, we're slowed back down to 1/4 speed. It will be sort of a left-handed roll. You can just see the ear of the anchor peeking out of the seabed at the bottom of the screen there. I can detect a ball of seabed attached to the toe of the fluke, and maybe that prevented this anchor from resetting faster, but it did eventually reset. Here's the second try with the roll bar removed from the Mantis. The anchor did better. Still have a rolling phenomena occur, but we'll see initially it was resisting 620 pounds nicely. I'm going to call that usable holding power or resistance. But then at 685 pounds, the anchor did roll out. We're going to briefly see one of the ears of the anchor emerge right there at the top of the screen, followed by an immediate release and a reset. Here's the third and final try for the 17-pound M1 without the roll bar. This time it was making good resistance at 535 pounds, and then at 620 it had a rollout and release. If I average those three roll barless peaks together, I'm going to say it's a 516-pound average, so it's a bit less than with the roll bar installed. And once again, we'll note that it rolled out about 90 degrees, followed by an immediate reset. So 3 for 3 on the rollouts, and of course with the roll bar, it was 3 for 3 on pop-outs. Okay, now we're on to the 12-pound Viking 7. We will look at 2 successful pulls to establish a baseline here with the roll bar installed. Keep in mind this anchor is, a whole category smaller than that 17-pound Mantis, so the numbers you'll see need to be, you need to consider that this is just a smaller anchor. So initially the anchor was not moving much at all at 465 pounds. Very solid, and that's a very good result. And then at 535 pounds, motion increased considerable, but it didn't release right away. It hung in there for quite a long drag. I'm going to show you the whole drag here in real time. The anchor has lifted a bit, but then it seems to sort of rebite and maybe move back down into the seabed, sort of an oscillation. But eventually there it did do a full release. I cut the power, of course, and the anchor did re-engage and brought the boat to an abrupt halt. Here's the second attempt for that 12-pound Viking 7. I'm going to show you the whole free fall here. The boat is not moving, and the anchor is just sort of falling straight down with no tension on the road. And sure enough, the anchor has sort of flown up and over and landed directly on the chain. Now I'm going to slow down the playback speed to 1/4 speed. Watch that chain in the very top there near the roll bar. The boat is off to the right, and it's now slowly pulling the chain tight. And it catches, the chain that is, chain catches on one of these little ear sort of flaps that the Viking anchors employ. And it does not become untangled. It stays like this. I drag the anchor for about 100 feet. And this is what you see is what you get. This is a really good example of why it's important to properly set your anchor. I make it a point throughout all my tests for all these years of doing this to just haphazardly deploy anchors just so that we can see things like this. Okay, here's my other successful pull here with the Viking 7 roll bar attached. it was pretty solid at 535 pounds. Then at 620 pounds, it started moving faster, kind of lurching. Took a bit of a distance, but it eventually had a full release. And certainly there's no rolling. It's more of a pop out, just a straight up kind of a motion. And then it did reset immediately after that release. So it's a good baseline for this anchor. I'm going to call it a 500-pound average usable holding for the 12-pound Viking 7. Okay, here's the first of 3 successful pulls with the roll bar removed from the Viking 7. Good initial set, and it was pretty solid. Very little motion here at 535-pound thrust. Then it was increased to 620 pounds, and we're going to see another rollout. Look in the upper, kind of upper middle left of your screen there, and you're going to see the ear emerge right there, and followed by an immediate release. Anchor is probably flying along there. We're moving really fast, but it did reset and stop the boat. This is the second try for the Viking 7 without the roll bar. Good initial set. I don't see any reason to believe that there's a problem with that set. Nothing in the way. I mention it because it released pretty quickly here. It was only 285 pounds. Everything was looking great at this point. I thought that was just fine during my ramp up, and sure enough, the anchor rolls out. We see the fluke is pointed skyward. The tip is nowhere near the seabed. It is fully upside down. And this is a really good example of why we should not use our anchors with the roll bar removed. This could certainly happen at any time, and once it does, the anchor is useless. It will likely never reset. Here's the third and final try for the Viking 7 without the roll bar installed. All these are nice, clean initial sets. The anchor did pretty good on this one. It did initially 465 pounds of thrust here with very little motion, just a little bit of creep ahead. That's certainly usable. But then at 535 pounds, the anchor had an abrupt release, and it executed a complete barrel roll and a reset immediately. Now I'll show you that roll again here at 1/4 speed. Don't know about you, but I'm fascinated by that kind of stuff. Here is the 3¼ pound Mantis dinghy anchor. This is previously seen footage, and it's really quite remarkable what this anchor can do. We'll see here that at 295 pounds, the anchor was hanging in there really nicely, but then at 380 pounds, bumped it up here, and the anchor immediately releases. But it resets just right away, stop the boat. In fact, I kept testing this. I won't show it, but this is the one where I was up to about 600 pounds when it released again, but the roll bar was bent back. And this isn't a bent roll bar test. This is a no roll bar test. So now we'll look and see how it does with its roll bar removed. I'll note that Mantis used to sell their dinghy anchor without the roll bar. It was a slightly different model. They made a few changes, and now it's just sold with the roll bar. We see there it had a release and a reset at 215 pounds of thrust. Then it repeated that, had another almost hold, but nope, then released again at 215. It resets once again, but this time it was holding 215 for quite a bit of time. So I held it there for a while. But then when I bumped it up to 285 pounds, we have another full release. And each time this anchor releases, it was rolling. You can slow down this footage if you want or stop it, and you will see the ear emerging from the seabed first. Just there to the left slightly of that setting track, I see the ear peeking up and dragging along, and eventually out pops the anchor. The anchor did remain upright enough to where it could reset, and it did, and stop the boat. Next, we'll test these 3 anchors in the soft mud over at Scow Bay. Not as many pulls. I'm only going to do 1 or 2 each just to save some time. Here is the 17-pound Mantis M1 with the roll bar installed. It was moving at 0 knots on the GPS at 395 pounds of thrust. Then at 465 pounds of thrust, obviously we can see some motion here. And I scrutinized this footage. There's just a teeny bit of evidence that there was a rollout on that release. But it did reset, and then you're going to see here on the reset that there's more evidence of asymmetry or rolling. Notice that the track in the seabed is misaligned slightly with the direction that the chain is pointing, and there's also kind of a lump forming. So again, I think that was evidence that there is rolling. And here's a pull with the 17-pound Mantis without the roll bar. And what it did was I saw 0 knots on the GPS with 285 pounds of thrust. 315 pounds of thrust saw 0.3 knots on the GPS. And then at 395 pounds, speed increased eventually up to 2 knots and had a full release. There was a rollout, and it ended up inverted. You watch this footage, and eventually we'll see the tow nowhere near the seabed. So again, this would have been a situation where the anchor would likely not reset. Just there we see the toe of the anchor peeking out of that ball of mud. Now it's the 12-pound Viking's turn here in the soft mud. Got the roll bar back bolted on. You can just see the roll bar diving out of sight as the pull increases, and this anchor just buries very, very nicely. Here we are with 315 pounds of thrust, and saw 0 knots on the GPS, but you can see just a little bit of creeping motion ahead. Then, as power was increased to 395, we saw more and more motion, and we get the plunging camera phenomena, followed shortly by a full release. The anchor did reset, but it did not make the same holding power as the first set. Here's another pull with the roll bar installed on the 12-pound Viking. Got the roll bar just diving out of sight there once again, and the performance was a bit better than the first try. Here we are at 395 pounds of pull with 0 knots showing on the GPS as a touch of motion. Then as we bump up the power to 465 pounds of thrust, it was 0.3 knots. We'll jump ahead here. Here's 535 pounds of thrust, making 0.7 knots on the scope. And then up at 620 pounds, the anchor eventually, I should say the whole boat, anchor, and everything was moving at 2 knots. But what's remarkable, never released. This anchor just stayed engaged, eventually just chopped the power, and I was just still anchored. So that's really remarkable performance. Again, it's only a 10-pound, correction, it's a 12-pound anchor. And here's the Viking without the roll bar in the soft mud. Performance is really decreased. We're only pulling 165 pounds here. Was 0 knots on the GPS, but then just bumped up to 215 pounds. The motion increased dramatically, and the anchor did have a full release. We'll see here in the aftermath of all that, after the boat's been slowed way down, that the anchor is virtually upside down. We're looking at the bottom of the fluke, and obviously that was never going to reset. It did come up with a significant ball of mud as well. Here's the 3¼ pound Mantis dinghy anchor, roll bar installed, soft mud. Nice initial bury. And here we're holding 100 pounds of thrust, very, very little motion. But when thrust is increased to 135 pounds, motion increases and it eventually, I believe, rolls out. Scrutinize the top of the screen when this sort of lump emerges right there. It was emerged to the left of the line of travel. The anchor did reset though, and it actually repeated this. I won't show you, but it repeated that same performance, and then the next reset wasn't as good. And I think it's somewhere along the line it picked up that stick. So I retested the anchor just to be sure. We really don't know when that stick came along. And for the second try here for the dinghy anchor, it was very similar to the first. So maybe we can say that the stick was picked up in the latter portion of that pull. But in any event, this try, it was the same story. 100 pounds of thrust was 0 knots on the GPS, and then with 135 pounds, speed picked up and eventually released. Now, when it lifted out of the seabed there, it looked pretty symmetrical, so I'm not so sure that was a rollout. I think it might have just been a straight-up pop-out. But no reset this time, or just a real marginal one. It eventually sort of brought the boat to a halt, but again, marginal reset. Must have been a big ball of mud clumped in there, and that may have fallen away on the retrieval. And for the Mantis Dinghy anchor without the roll bar, it's just like every other anchor and every other test for this video. And that is, when you take the roll bar off, it just doesn't work as well. Only 75 pounds of thrust was showing 0 knots up on the GPS. 100 pounds of thrust resulted in a complete release. It was a rollout. The anchor is upside down at this point here in the aftermath. No chance of resetting, obviously. Going to see a fair bit of mud still clinging to the fluke, and it's pretty clear. Taking the roll bar off from your anchor is just not a good idea. Well, as I stated in the beginning, I had no idea that that rolling tendency was going to happen, and it obviously overshadowed my other theories about how this removal of the roll bar would affect the anchor. Now, why is the anchor rolling more when the roll bar is removed? Well, first let's just look at what's going on. All three of these anchors have these ears, and they are oriented at the same plane as the main fluke. So if the fluke is pointing down and creating a downforce, so are the ears. And if the anchor starts to tip a little bit for whatever reason, the ear that is lower will be in deeper, thicker, and more dense solid seabed and create more downforce. The upper ear is going to be in more shallow seabed, or perhaps even clear of the seabed, and in that case, the rolling is going to be aggravated. We're going to get more force to roll the anchor. Why does adding the roll bar disrupt that or make the anchor more stable? I think there's a couple factors. The roll bar tab adds thickness, and just the presence of the roll bar and the bolts, I think they tend to just maybe disrupt whatever force that these ears have. Now, in the case of the Viking anchor, there's even another factor which is more obvious, and that is the roll bar tab also contains this downturn flap. I believe that has the effect of changing this whole ear from a downward force kind of plane to one that is now tending to push up. So if these ears are pushing upward and it starts to tip a little bit, well, the downward ear is going to have, again, more power. But since it's pushing up, it's going to have a tendency to self-stabilize the anchor. Now, unfortunately, the shape of this tab is such that it can catch the chain. We saw in that one haphazard deployment that I made where the chain did get hung up and it was just caught right here in this notch, and anchor never did set. Perhaps a better shape would be one where this notch was eliminated. Maybe this sort of angle could continue all the way over to this point, and maybe chain would have a better chance of just sort of skipping over. Now, if my theory about these ears acting like wings and causing the anchor to roll, maybe it explains why that recently tested 45-pound Mantis M2 anchor might explain why it has a bit of a tendency to roll. Otherwise, I don't have an explanation. So a cool test might be to heat up one of these anchors in this vicinity and bend the metal here so that the ear is pointing in a more upward direction, thus changing it from a downforce sort of plane to an up force. Now, probably not going to do this without the blessing of Mantis anchors, and frankly, I do not have the time or money to do a whole lot of sort of R&D testing on anchor design. So if I get inspired, maybe that'll happen, but in the meantime, there'll be more just normal anchor tests coming soon. Cheers.